Okay. So what is a power system? Basically, a system which deals with the business of, basically what is the business is three: generation, and then after the generation we have transmission, and distribution. Distribution of what? Of electrical energy. Electrical energy. So a business, that's a type of a business, or that's a type of a system which will deal with these three things. So what are these things? Generation, transmission, and distribution of electrical energy. This is the power system, and this is the most complex man-made system. So we also call it a very complex man-made, it's a very complex man-made system. Okay, and if we talk about this complexity of the system, then this is spread. We can say this is spread over a wide geographical area. Very large geographical area will be there, and this is spread over that. So that's what we represent the power system. It's a complex man-made system and spread over a wide geographical area. Okay, this is the definition of the power system. Now, if we talk about, out of this first, which we'll be dealing with unit number 1 today, unit 1, and we are talking about unit 1 is about per unit representation. So if we talk about the per unit representation, definition of this per unit representation. So per unit representation is basically what, in a simple language, it will attempt to what? It will attempt to scale down the various parameters. There can be components, there can be variables. How? Whichever it will be in the system. Maybe there are voltages, current, and then can be complex power, then voltage, current, complex power, real power, all other things, whichever the quantities are present in the power system. The basic aim of the per unit system will attempt to scale down the various parameters. It will try to narrow down those various parameters, whether they are components, whether they are variables of system. How? In such a way that there will be a uniform treatment of the entire system. That means a homogeneous treatment of the entire system. It's nobody. Okay, so we can write that per unit system does what? It attempts बस इनका काम यही है. They will never come in the time. What is that? Per unit systems attempts to scale down. Attempts to scale down the various parameters. What is this? Various parameters. Out of these parameters, what can be there? They can be values of the components. Values of components. Any machine is there, nameplate ratings or other values, or any variable is there in a power system. So variables of a system. How? In such a manner so as what? Such a manner as to permit, in such a manner as to permit the homogeneous, that means uniform treatment, permit the homogeneous treatment of the entire system. So in a simple language, it is a system in which we will have a very complex values, very different values. In a sense, complex means in the sense the values will be in the numbers will be large. The system, the per unit system will have an objective to narrow down those values from 0 to 1. So those bigger values, whether they are in kilowatts, whether they are in kilovolt amps, whether they are in megavolt amps, whether they are in megawatts, such a large quantities of various multi-level voltages at the different milestones of the power systems will be narrowed down to a very small values whose calculations will come easy, and then there will be a complete homogeneous treatment of the entire system. That means in a homogeneous treatment of the entire system here means that if we have taken a particular base value, we have chosen a base value, then the base values will be made uniform at the different levels of the power system. See, you can see the discontinuity in the power system will occur in case when the transformers will be present. In a case, suppose we have a step-up transformer, we have to step the voltage from 11 kV to 132 kV. Then we need to distribute them. Then again, we have to step down that. So discontinuity in the power system will be, that discontinuity here will be negated in a sense that we will treat the entire system homogeneously, and a particular the voltage levels will be calculated as per the base values. So we'll come to those base values. What are these values? So the values will be in nutshell, the values will be narrowed down, and that narrow range will be from 0 to 1. So that's the per unit system. So if I will say in this case, what is, somebody will say, what is the reason, sir? I will tell you after that advantages. So one of the reason for representing a per unit system is, I'll say there are a number of reasons, but one of the reason in representing PU system is what? As I have just now told, what is that? One of the reason in representing per unit system is that power system will consist of various equipments. So we know we have generators in the power system, we have transformers in the power system, we have transmission lines, then we have protecting relays, circuit breakers, then we have loads. So power system will have a various equipments in that case, which will have a very wide varying ratings. So those, all the equipments will have all those equipments will be having, which will have a wide varying ratings. So that means ratings of these equipments will be different. And then what will happen if there are wide varying ratings, and if we use all these different voltage levels and power levels, then there is always a chance of making mistakes. Okay, so that what we are writing here, that power system consists, it will have equipments which will have a very wide rating. That means all the equipments will have different kVA, real power, reactive power, other ratings will be different. We'll see that voltage ratings will be different. So when these ratings will be different, then what will happen? If we are using all these different voltage levels in analyzing the power system or in calculating some values, then what will happen? There are always chances of making mistakes because the values are very higher. The numerical values are very high in terms of megawatts, megavolt, amperes. So chances of making mistakes will be higher. And then what we write it, and if we use, just a second, and if we use, just a second, and if we use all these different voltage levels and power levels, whatever the voltage we have, power, complex power, real power, what are the levels we have, then there is always chance of making mistakes. Okay, then there's always chance of making mistakes. Why? Because these ratings are very high, because the ratings are in terms of kilowatts, kilovolts, megawatts, etc. So when these ratings are very high, then there's always a chance of making mistakes. So this is what is the main reason that why we use a power system. There are some other reasons also, but this is the main reason. Okay. Now next is, what are the advantages of the power system? Per unit system. Why we use per unit? There is absolute system. There are three systems. We use two systems, absolute systems as well as. So let us see that what are the advantages. Before the advantages, we need to go into the objectives or aims of the power system. I should have written that first. Objectives of power system. So what are objectives of power system? Moomin, can you tell me what are the objectives of power system? Moomin,
Yes, sir.
what are the objectives of power system?
सर पावर डिलीवर करना कंज्यूमर्स तक.
और वो तो करना
सर
ही है
हमारी.
उसको,
यस सर.
वो तो वैसे भी करना ही है. जब आप पावर सिस्टम बना रहे हो तो पावर के लिए कंज्यूम, वो तो, मगर कंज्यूम करना है, डिलीवर करना है किन चीजों पे, किन शराइत पे, ऑन व्हाट?
सर हमारी जो एफिशिएंसी होनी चाहिए पावर की, वो ठीक होनी चाहिए.
दैट्स करेक्ट. Any other? Roll number 26, Mansha.
Yes, sir.
What are the objectives of power system? That means
Reliability
why?
should be high.
What should be?
Reliability should be high.
Yeah, that's
Operation
correct.
cost should be low.
Very good. Operational cost should be very low so that everybody can afford that cost. Okay. It's a commodity and which should not be very high. So let's see what are the objectives of power system now. So number one is cost of one unit. Cost of one unit, or we can say 1 kilowatt hour. Unit is equal to 1 kilowatt. Everybody knows that. Kilowatt hour energy, that should be minimum. Should be minimum. So number one objective is this one. Let me add a paper. Number two, what's the number two objective? Number two objective is fluctuations in voltage and frequency should be minimum. Why they are required? If there are fluctuations, then our devices will not work properly. If the ratings are very less, what are the normal ratings of the devices, and we are not able to get those ratings, then a time will reach, the device will stop working and it will become almost defunct. So it's very important that it works on the operating ratings which are written on the nameplate. So that's why there has to be fluctuations in voltage and frequency should be minimum. So we don't advise a power system where there will be lots of fluctuations in voltage and frequency. As a result of this, what is going to happen? Whatever the gadgets and devices which are in our house, those devices will not work properly, in sense that we will not be able to get the proper ratings for them, and the time will reach, there will be deterioration in their performance, and the time will not be far away when the devices will almost stop working and they will become defunct. So it is very important for that we receive a very robust voltage which will have fluctuation, but that are allowable changes in the voltages. I have told you plus minus 5%, 0.95 per unit to 1.05 per unit is allowed in a power system. So 5% fluctuations are allowed, but beyond that, they are not admissible for the proper operation of the devices which will be present in our houses. So it is very important that these should be minimized. The fluctuations in voltage and frequency, both should be minimum, and that should not affect our devices. Otherwise, there will be problem with their operation. And third is very important in case of occurrence of fault. See, faults we have not studied. Fault is basically an abnormal conditions when there can be a change in the operating voltage, operating current, so that power system will not operate properly, in a sense that there can be line to ground fault, there can be other faults, triple line ground fault, double line ground, any kind of fault can be there, and then that system will not work properly, and then those things we have to minimize. So in case of occurrence of fault, what we have to do, normally when the fault occurs, what we do, we isolate the faulty section of the power system from the healthy section. Healthy section means where there is no fault and it's working properly, it's working as per the operational requirement of the system. That means voltages, current, everything is in line with the design operations. But once a fault will occur, then what we'll do, we will isolate the faulty part from the healthy section of the power system. It should be done in a it should be done very fast, in a minimum time. So we can write here, in case of occurrence of fault is an abnormal condition. In case of occurrence of faults, the faulty section should be isolated. Faulty section means there will be a relay. Relay will give a signal to the circuit breaker. Circuit breaker will isolate that by closing or opening the contacts. Relay will open or close the contact, giving a signal to circuit breaker, and circuit breaker will isolate the faulty section. The faulty section should be isolated from healthy section. Should be isolated from healthy section. This is the way we isolate that, so that we can isolate it very quickly, so that fault will not spread to the other areas, other healthy areas. Otherwise, it will cause us considerable damage in the power system. So we use a relay and we use a circuit breaker to isolate it and keep it within a particular area, so that we can repair it. After that, a shutdown can be taken, or it can be repaired as fast as we can. So should be isolated from healthy section in a minimum time. It's very important, because in a minimum Why minimum time? Because if we allow the faulty, if the fault occurs and we are not clearing the fault, we are not isolating the faulty section, then it will spread to the other parts of the sections of the power system, and it will do a considerable damage to the equipments or the devices which will be present in the power system. So it should be, fault should be identified. Once it is identified, it should be in a minimum time, it should be isolated from the healthy section of the power system. That's very important. And next is, there should be uninterruptible flow of energy through the transmission line. Although fault will occur, but this is the ideal case. There should be, this is what is the requirement. Uninterrupted flow of energy through the transmission line. So there should be no interruption. If there is interruption, we need to clear the fault and we need to regulate the force supply within a minimum time. So that's what is the requirement. Next is power system network. We have power system network that can be represented by the two forms. Okay? These were some of the objectives of the power system. So also everything comes that operational cost should be less cost per unit, that I have already told you. So power system network can be represented in two forms. How we represent normally the power system network? Network can be represented in two forms. So what are those forms? Number one is absolute representation. And number two is per unit representation, which we are studying. So two things we have. Two forms we can represent the power system. We can analyze the power system in two. So these two are absolute representation. That means your kilovolts, everything values will be there in actual values. Absolute means actual values. Per unit means only we have per unit values. So we'll come to that per unit value, what that actually means. Now, what are the advantages of per unit representation? Why we are studying it? When we are talking about it, why we are studying it? What advantages of per unit representation? So what are the advantages? Let's see. Number one, if we talk about the advantages of per unit system, there are lots of advantages. Okay, I'm not going to write those all. I can later send you some of the, but what are the important ones, I will write it. So if we have a power system that will be containing several transformers, and then there will be several transformers, then isolating, that means there will be different multi-level voltage. Multi-level voltages will be how? Because if we start a transformer from the generating station, then we can step it up. We will have transformer, step-up transformer. So it can step it up from the 11 kV to 132 kV. Then we have a transmission line. We'll transmit that in a high voltage. Then again, we'll step it down in the distribution side. So that means we will have a number of transformers in the power system, in a section of a power system or in a power system. Then there will be multi-level voltages. Once there will be multi-level voltages, per unit system will remove this discontinuity in the voltage levels. What is the discontinuity? That means the multi-level voltages. So per unit system will remove, or in other cells, it will provide a scaling that will allow to remove the ideal transformer part of the transformer circuit model, in a sense that it will provide a one level voltage only. This is the first advantage of the per unit system. Okay. So I will write that per unit representation converts multi-level voltage circuitry into the single level voltage circuitry. This is the first advantage. That will not be in the absolute system. So PU will write now from here onwards. PU means per unit representation. ठीक है, converts multi-level voltage circuitry into single level voltage circuit. So per unit representation will convert multi-level. So I have told you I can provide an example like this. See, we have a this is your power system. Then we can have transformer like this. For example, what is the meaning of this? This is transformer. Sorry. This is a transformer. Okay. Again, another transformer. Then okay, so this is a load. So let's say this is a generator. Generating side, let's say we have a step-up transformer. From where? From 11 kV is the generating voltage to 132 kV. So this all is a transmission line. So 132. Now we'll step it down from 132 kV to 6 kV. Okay, then we have a load. Load can be anything here, like motor, synchronous motor, induction motor, or normally a load can be there. So now we can see clearly per unit system will do what it is the actual system. This is your absolute system. This is we are talking about in the absolute system. Now absolute system we will have multi-level voltage. See here it's 11 kV. We have 11 kV and then we have 132 kV. Here up to here it will be 132 kV. So here will be 6 kV. So 1 level, 2 level, 3 level. So we will have a multi-level voltages. So per unit system is the best system that will go what? That will convert this multi-level voltage into a single level voltage. That we'll see how we will do it. We are not talking about that right now. We'll take a base. There will be a common system base that will be complex power base will be common and the voltage basis will be calculated. Before every transformer, the voltage basis will be calculated and accordingly that we will convert that into the multi-level will be converted to single. That will be single voltage base will be there and single complex power base will be there. That we'll see in the coming lectures. So this is the first advantage. Now, second advantage is what I've been talking about just now, right now, that reactance of the transformer referred to the primary side is same as referred to the secondary side in per unit system representation. So what is that? Reactance of transformer referred to primary side is same as referred to secondary side in per unit representation. So that we have to see, there is a derivation for it. We'll see that on primary side, reactance or impedance will be same. While as an absolute system, we have a different this reactances on the primary and secondary side. But per unit system, we will see in the coming lectures, once we derive that expression, that reactance on either side of the transformer will be same. So we don't have to change. We can refer to any reactance. So that will be seen. This is an advantage in the per unit system. Number third advantage is the numbers involved during calculations are of wide range in absolute system. Okay? Whereas they have narrow range in, I have already told, they have very narrow range in case of per unit. That means 0 to 1. So third is the numbers involved during calculation or of wide range in absolute representation. Okay, whereas they have narrow range in per unit representation. So again, the meaning is same, that in per unit representation, we have to calculate various loops. That means suppose here will be 3 loops. So lots of values will be involved. The values of the values will be very high. But per unit system, we have a narrow range that will range from 0 to 1. And this is very important in case of the per unit system. Next is manufacturers. What manufacturers and equipment manufacturers, electrical equipment manufacturers, they usually specify the impedance of a piece of apparatus in percentage or per unit in terms of the base of the nameplate rating. That means every value, if you see in the electrical equipment, they will be on the base of the per unit system. So that is another advantage. So next we can write manufacturers usually specify impedance of a piece of apparatus in percentage or per unit in the base of nameplate rating. That means there will be some base will be chosen. So manufacturers will also specify the ratings of the various equipments in terms of the per unit. So we also need to take the advantage of that. Next, we can say that there are some other advantages also, that voltage regardless of the high tension side will be same, other things. So these are mostly important. Per unit system allows homogeneous treatment of the entire system of the various types of analysis. एक हम लिख लेते हैं, fifth allows homogeneous treatment of entire system for various types of analysis. Okay. So last is it will allow you the entire, for the entire system, the homogeneous treatment of the system can be done. So these are some of the, there are certain other advantages. So we can also look into those advantages later on. But these are the main advantages which we know for the time being. Okay. Now let me talk about the difference in, there's another very important thing that we are talking about, absolute system and the, what is the difference between absolute system, absolute representation, and the, what is the main difference between the absolute representation and per unit representation? So we will have here absolute representation okay. So absolute representation and the per unit representation. Okay. Roll number 3, Umar. Roll number 3 is there. Roll number 3.
Yes, sir.
What is the difference between? क्या एक difference बता सकते हैं आप? What's the main difference? Absolute representation and the per unit representation में क्या फर्क है? Okay. Number one difference which we can say, number one difference is number of equations required to solve network is equal to number of operating voltage levels. So number of voltage levels will be there, so number of equation. That means in different places voltage levels will be different, so the loops will be there, KVL loops can be applied, and that will be the number of equations. But in case of per unit system, we will have only one. So number of equations, number one is number of equations required to solve network is equal to number of operating voltage levels. ठीक है? So that means how many voltage levels in a system we will have, it will depend on the number of equations, will entirely depend on that only. So we have 3, it will be 3, we have 4 in a power system, so it will depend accordingly. Okay? So this is for the absolute system. But for the per unit system, you should always remember number of equations to solve network is equal to always 1. Number of equations required to solve network is equal to 1. So in case of per unit percentage, it is always 1. We'll see that because voltage level will be same, and then it doesn't make any sense that we will use number of equations will also always will be 1. All the electrical quantities are represented with units. In this case, what will happen? All the, suppose There is a power that will be in kilowatts or watts. There is a voltage, kilovolts or volts, current, kiloamperes or amperes. So different electrical quantities will be represented in units. All the electrical quantities are represented with units. So definitely units are there in case of absolute system. All the electrical quantities will be unitless in this case. All the electrical quantities will be unitless in this case. So there will be no unit. We'll see that. Now third is performance of all the equipments of the power system networks are evaluated one by one. That means we will go to the section, first section of the generating section, then we have a different voltage, multi-voltage levels will be there. We'll move to the next section. So performance will be gauged or performance will be seen. Evaluation of the performance will be done one by one. But in case of the per unit system, performance of the equipments which are present in the network are done simultaneously in that case. So here we will see performance of all the equipments of the power system. So this is a power system, you need to know this. Networks are evaluated one by one. So in this case, performance is evaluated in various sections. It is evaluated one by one. Performance of all the equipments of network in this case. Performance of all the equipments of network are evaluated simultaneously. That means we can do it together. Simultaneously. Simultaneously. Okay, so we can do that simultaneously in this case. Fourth point is, in this case, the calculations required are very large, more calculations required. So in this case, per unit system, calculations required are very less. So computational effort required is more. Computational effort required is more. Computational effort required is less. So this should be very clear in that case, because we have multi-voltage levels, large values of those voltages. So that will be very, it will be very large. The calculations will be more complex. But in case of per unit system, it is very less. We don't have much calculations to do in case of per unit system. Next is evaluation time. So one, computational effort will be more, evaluation time will be more. So evaluation time is more. Very clearly in this case, evaluation time is less. So these are some of the differences in absolute and per unit representation. Okay, so we'll Today was the first introduction class. So we'll continue with this classes. Please make sure कि Momin,
Yes, sir.
attendance भेजना. I am telling everybody, please, I am announcing this to everybody. This time, whosoever will fall short of attendance will not be allowed to. First go for the internals, then for the external. ये सर ने कहा इस बार attendance बिल्कुल इस बार strict. Last time we will not, क्योंकि अब ये तीसरा चौथा session है. Now we don't know, this year we'll be able to go, we'll be able to join the class works. This is a virtual class work. We'll be able to join the real class work or not. Nobody knows that, inshallah, hopefully. But till that, make sure that you have attendance of 75%. Otherwise, now you will be detained. ठीक है? Okay, Mumin, आप भेजो मुझे ये log. So we'll continue with the ये power system 2 बड़ा important है और बड़ा interesting भी है. It's a mathematical subject. पहला थोड़ा है इसमें. We have 1 or 2 classes. एक दो classes हैं theoretical ये. Then we'll move to the what you call it numerical. न्यूमेरिकल अप्रोच ही है. पहले 3 चैप्टर्स में तो वही है सारा. मोमिन,
Yes, sir. भेज दो मैंने.
what I will stop recording.